Hello, I'm going to present this work called Pectinase Immobilized on Corsel magnetic nanoparticles for use clarification. My name is Arely Núñez, and I'm from the Universidad Autónoma de Nuevo León. Okay, enzymes are an eco-friendly biocatalyst. Pectinases are useful in food industry in clarification. And enzymatic immobilization is a technique that allows easy recovery and reusability, and different methods and materials have been used. But magnetite nanoparticles have been of interest due to the easy recovery by magnetic fields. To prevent oxidation, it could be coated using biocompounds such as silicon dioxide and chemically modified with functional groups. Okay, for methodology, commercial magnetics were coated with silica dioxide and dispersed in a solution of aminosylated to synthesize the amino cordial using glutaraldehyde as covalent bond. Morphology, size, and surface chemistry were determined by SEM, X-ray diffraction, zeta potential, and X-ray photoelectron spectroscopy. The absorption capacity of the material was determined by the enzymatic rotation, immobilizing pectinases on activated cultures. The kinetic the free and immobilized pectinases were determined by the Michaelis-Menten model. The clarification was evaluated using the equivalent catalytic units of the free and immobilized pectinases and used orange juice. The turbidity was measured 600 nanometers, and reusability was evaluated in 5 cycles. For results, the recovery nanoparticles magnetite presented a black color characteristic of magnetite, and micrography shows less agglomeration, an average diameter of 150 nanometers by the surface reaction. Okay, amino-incorporated functional groups were successfully performed based on the zeta potential measurements. Characteristic of absorption peaks of magnetite were observed. In addition, a signal of 23 degrees was detected, corresponding to amorphous silica dioxide, conforming the shell formation. The magnetite spectrum shows energy signal for iron, oxygen, and carbon. After siliconization, a peak corresponding to silica was identified, and after chemical modification, nitrogen was identified, confirming the amino functionalization of the support. 80% of the initial activity of pectinase remained when it was immobilized in the Corsel nanoparticles. The substrate affinity was reduced after immobilization due to a limitation to the access to the active site, according to the value of Km. And the Vmax value of the immobilized pectinase was similar to the free enzyme, which indicates that a rate of hydrolysis didn't change significantly after immobilization. After 16 minutes of operation, no significant difference was observed in the free and the immobilized pectinase, and the mechanical treatment achieved a 36% in cloudiness reduction. The immobilized pectinase achieved 84% of relative activity after 5 cycles of use clarification. And as conclusion, magnetic nanoparticles recovered after silica dioxide coated and chemical modification by amino groups show magnetic properties. Theta potential and XPX results confirm the correct chemical modification of the cortical nanoparticles. A 30% reduction in derivative induced with free and immobilized pectinase. And the covalent binding of the enzyme in the cortical magnetic nanoparticles is a promising option to increase the stability and reusability of commercial enzymes. Thanks for the attention.